The next section, which involves render materials, requires an extension plugin for Grasshopper called Human. If you don't know how to install plugins, it is explained in a separate video. Repeating what was said earlier, the goal is to link each vertex of the mesh to a point in the image. The first step is to find out where on the image each mesh vertex is. This is done with Surface Closest Point under Surface tab in Analysis toolbar. The points that form the Delaunay mesh should go to the point's input, P, and the surface param to the surface input, S. Fortunately, the Delaunay mesh component does not affect the order of the points. The output that we are interested in is the UV point output. UV coordinates are just like XY coordinates, except that instead of being in an abstractly flat plane, they are embedded on a surface. That surface can be rotated, stretched, or curved, so you can think of UV coordinates as a graph printed on a rubber sheet that deforms to follow a surface and its curvature. And in the same way that the Z coordinate is the distance above or below the XY plane in the orthogonal direction, the W coordinate is the distance offset in front of or behind the surface, also orthogonal at that point. This is called the normal vector. The coordinates that come out of the surface closest point component will be scaled depending on the size of the surface. But what you want here is for the bottom left to be 0, 0 and the top right to be 1, 1. Right-click on the surface input, S, and select Reparameterize, which does exactly that, bracketing the dimensions in a 0 to 1 scale. Selecting the image in Rhino and opening Object Properties and the Material tab, you can see that this is just a rectangular surface that has had a render material applied to it, specifically a texture map. The next tab, that looks like a wrapped checkerboard, is the Texture Mapping tab, and it determines how the image is placed onto the surface. If you were to switch the last figure in UVW rotation to 90 degrees, it will rotate the application of the image 90 degrees around the surface normal. Because the type of mapping is surface, it stretches to fit the dimensions of the surface. For the next steps, the mesh should not have an even surface mapping, but be mapped such that every point holds a consistent UV coordinate reference, no matter where it is moved to. Returning to Grasshopper, select the Human tab and find the Texture Mapping tab. Select the rubber ducky, Custom Mapping, and place it on the canvas. The M mesh input will come from the Delaunay mesh, and the UV coordinates input will be the UVP output of surface closest point. This doesn't change anything visible, but the output mesh is different from the input mesh because it now has the texture mapping information saved in it. Using another component from Human, Object Attributes from the Reference tab, you can extract the material from the surface. Using a custom preview component from the Display tab, Preview toolbar, the texture mapped mesh can be connected to the geometry input, G, and can be previewed with the Object Attributes material. Unpreview the Delaunay mesh now to remove the red overlay caused by trying to display both the unrendered and the rendered mesh. If the image is not appearing, try right-clicking on the black bar that says Preview and toggling the render button or changing the viewport display mode. Exporting geometry produced in Grasshopper back to Rhino is called baking the geometry. Normally, this can be done by simply right-clicking on the Output Geometry node, selecting Bake, and assigning the layer it should bake onto. Note that this completely severs any connection with the Grasshopper definition. If you change something in that definition, it will not be reflected in the baked object. You will have to rebake. Nor will editing the baked object reflect back into the Grasshopper definition unless it is re-referenced in a new param